Okay. So today we're going to be talking about functional programming. I've just started learning the basics of functional programming, and mostly in JS. And this is going to be a series of, I guess, 3 to 4 sessions, and we'll be covering different parts of functional programming in JS. This is just a start. To learn more about functional architecture in our JavaScript applications, but we'll be mostly focusing on just functional programming by itself. Uh, so, uh, so what's functional programming? Functional programming, as you can tell by the name, it's programming with functions. What does programming with functions mean? What we're going to be generally be learning today is how to do point-free programming with currying and composition. And then in the next sessions, we'll be moving towards more dot syntax using functors and monads. These are terms that you will get the grip of as we progress throughout these sessions. We all know what a function is, but let's define it together again. If we use the set theory, a function is a single valued collection of pairs. Um, on the left-hand side, what you see is a function, and a function produces an output per input. So if you provide like -2 to a function, the result that you get or the output that you get is -1, 0, 0, 2, 1, and so on. But what you can see on the right-hand side, this is not a function because we provided 1 as an input and we received D as an output. Everything's okay. We provided 2 as an input. We received B as an output. Still, everything's okay. But if we provided 2 as a second time and we received C as the output, this is not a function. This is a relation. A function becomes a relation when the rule of one input per one output per input is not satisfied. The basic rule that we need for function is that we have to have a maximum of one output per input. The way that we used the set theory to display functions here, the inputs are also known as the domain of the um, function. So the -2, 0, 2, 4, and 8 are the domain values, and -1, 0, 1, 2, and 4, which are the outputs, are also known as the range of the function. One rule to remember is one input to rule them all. We can display functions using different types of representations. We could use a simple table. As you can see, the inputs are in one column and the outputs are in another column. This is one way. We could also use plots for representing functions. As you can see, each value on the x and y axes would be the representation of an input and output pair together. You could also use like you can also use AI, for instance, to train computers to learn functions. So after a while, they know what kind of output is expected based on the type of input you are going to be providing to that function. Again, we could also use bracket syntax to show a different representation of functions. For instance, if we have a function called toLowercase, whatever you provide to it, it outputs the lowercase um, type of that string. In the bottom example, we have the isPrime function that tells us which number is a prime number or not. Again, this is not a useful representation, and it's not logical to represent functions using bracket syntax because sometimes the the bracket syntax wouldn't suffice, and we'd have a really long list, such as the examples that we have here. Um, but we are living in the computer world and the programming world, so we would just use the function syntax that we have based on the programming language we have. Okay, so uh, s when we're talking about mathematics, the thing that comes to mind, like for in the example that we had here, is prime. We can generally, well, in the domain of mathematics, we know which number is a prime number or not, or we can do some calculations to find out if it's a prime number or not. When we're using programming, it's a bit different, and we need three different tests to be able to tell if something is a function or not. Okay, so the first one uh, is a function is total. The second one is that a function is deterministic. The third one is that a function has no observable side effects. And we'll talk about each of these one by one. The first one is total, and that means for every input there is a corresponding output. So if you provide an input again and again and again, you still get the same output again and again and again. We've got some examples here. I've got an increment function. Uh, we've written the body of the function in two different ways. In the first one, it returns different numbers based on the index, but based on the value that I has. But here, what happens is that it returns just it adds one to whatever the value of I is. The left-hand side is not a function. We don't call it a pure function or function because it's not total. Because what happens if I give the input of like if the value of the input is 4 or 5 or whatever else. Um, So this is not a function because it's not total. But this, on the other hand, is like if I provide whatever number, I will get an output for it. But on the left-hand side, some numbers might not have outputs. We could also say that the left function is like a total function for the domain of numbers between 0 and 2. If we were using something like TypeScript and the type of this increment function was a function that accepted an enum that had the values of 0, 1, and 2, then yeah, there would be a total function, but that's not the case here. Okay, so again, we have the same left-hand side function that's not a function because it's not total, but by adding a simple return 100 at the end, we have we have outputs for whatever value is provided as the input. So we can change this function into a total function, a complete function, by just adding this one line. Again, the logic is stupid and silly here, but at least it's total now. No, and I forgot to say that total functions are opposed to, are in opposition to partial functions. The left-hand side is a partial function. It only works partially for a small proportion of inputs, and the right-hand side is a total function. Okay, so the next one is the function has to be deterministic. I'd like to call it being reliable. So deterministic functions are reliable functions because they always receive the same output for a given input. If you give it 2, it always returns 4, or if you give it like 10, it always returns 20. No matter the environment, no matter the situation. So the next fact is that it has to be deterministic. Let's take a look at two different functions. We have a function on the left-hand side. It receives a post object, and we want to check if that we want to check the difference between the time that the post was created and now. So if we run this function with a specific post as the input, we might receive an output of, like, let's say 2 days and 3 hours, but if we run it again tomorrow, we will receive a different output. So this is not a deterministic function. It's not reliable. You cannot count on the output that it produces. But on the other hand, we have another function here on the right that's get difference, and what it does is just it calculates the difference between 2 times now and then, and so the value will always be the same if you provide now, like the date now for now and yesterday for then, and you calculate the difference, it will always be like 24 hours or a day or something like that. If you run it in another like 100 years, it will still be the same. Okay, so the next one is the function must have no side effects. And pay attention to the word no observable effects besides computing a value. Th there's a lot of debate about the no side effects thing. I'll talk about it a bit using the example that I have here. So what we have on the left-hand side is not a function. It is a function because it is using uh, the bad arrow syntax for defining for declaring a function, but in the functional programming domain, this is not a function because what it does is that it's adding something to the console, and the console is something outside the scope of this function, and you're affecting the outside environment by logging something to the console. So this is not a function that this function has effects on the outer world, whereas this function uh, it's it's doing the same thing, but what it does is that it returns an object that has result as a key value, a key, and the value is the addition, and another key called log, which is the string. Um, and we can leave this section to the outer world to decide what to do with it. One might want to show an alert, one might want to show it in the console, one might want to like show it in an input or something. So it's kind of the same syntax, but what we're doing is that we know that this function, whatever the input is, we don't care about the input, will always return an object that has key values for making decisions based on it, but this one doesn't. Um, but since I said there's a lot of debate regarding this, like some people come up with stupid reasons saying that like, I don't know, uh, doing this addition will make my CPU usage or memory usage increase. Therefore, this function is affecting the outer domain. No, we're just talking about functions inside a file or just inside an application. That's the kind of scope we're talking about. Okay, so a few more examples of the same thing. As you can see, we've got an array, 1, 2, 3, 4, and 5. We're going to be running multiple splices and multiple slices on it. When you run splice on it, splice is not a function. Why? Because if you run it once, you get 1, 2, 3. If you run it again on the same array, you'll get 4 and 5. And then if you run it again, you'll get nothing in the end. Okay? But slice acts differently. What happens is that once you run slice, you get 1, 2, 3. You run again, you get 1, 2, 3. You'll always get 1, 2, 3, no matter how many times and when and where you run this function. So slice is a function, but splice isn't. Another simple example is that here we have a toSlug function. What it does is it just replaces parts of a string. It turns it into a URL friendly string. Um, the reason that this is not a function is that it is throwing an error, and throwing an error is something outside of the scope of this function. It could introduce breaks to an application, or I don't know, stop things from running. So throwing an error causes this function to affect the outer world or outer scope of the function. But on the right hand side, we've got the same function. And what we do is that this function always returns a promise that if like the promise runs into an error, if something happens that wasn't expected, what we do is that we return an error for that case. We do not throw an error. So this function is a function that either returns a friendly URL or it returns an error, and you can make decisions based on that error. This is very similar to the console log example that we had. I just wanted to mention that the fact that throwing errors causes a function not to be a function anymore. Whereas if you return a promise that handles the error and returns an error in the case of an error, you are doing things right, and this is called a function. Let's take a look at another example. Here on the left-hand side, we have a sign up function. What it does, it gets some attributes, it saves the user attributes, and then it welcomes the user. This is not a function because we don't know what's going on here. Okay, we don't know what save user does. We don't know what welcome user does. They could be doing anything. They could be affecting the outer scope by themselves. But again, if we change this, this is again similar to the console log example. What we're changing this to is that we're returning a function that returns an object that always, sorry, we're returning a function that always saves the user and welcomes the user. Where we have kind of like scoped the things that happen in that function. Therefore, this is a function because it has no effect on the outer world. It's a function that runs another function. Actually, it's a function that returns another function. Okay, so um, let's play a game. We're not going to play Among Us, though. I don't know, although I would really love to. You guys can turn your microphones on and tell me if this is a function or not. What? Why? Exactly. Exactly. What we're doing is that we're mutating the age value of the user object. So if you run it once, the age will be like if the user's age is 17, you run it once, you get 18. You run it again, you get 19. The value keeps on changing based on, even though the input hasn't changed at all. Good, thanks. So what about this one? Is it a function? So, so it doesn't return anything. So is it a function? It is a function, yes. So if you provide it with a word, what it does is that it changes the letters of that word to uppercase and it adds an exclamation mark at the end. So this will always happen no matter what. It has no effect on the outside world. If you provide it with the word hello, it'll just make the hello world full blocks, full caps, and add a add an exclamation mark at the end. Good. So what about this? Is it a function or is it not a function? Okay, so you think that it's not deterministic because we are sending different header selectors? Why is it a function? Okay, okay. Anyone else? Okay, okay, okay. Well, this is not a function. It's the same as console log. We don't know what query selector is. Okay, if we had passed query selector as an argument to this function, yeah, then this would have been a function. But again, we don't know what query selector is, so we might be influencing the outside world. Again, this is not a function. What about this? Why isn't it a function? Good, good, exactly. Good point. We don't have an input here at all, and this could produce something different. Like if the browser APIs change or whatever, location could be acting differently. So Yeah, there's no input, but it could have an output. And again, we don't know what location search is. So to make this a function, we would have to send location search as an argument into this function. Okay, so what about this one? I think it's the last one. Yep, it is a function. No matter all the clutter that's going on inside what this function does is that it gets a query string as an input and it returns the params. So these params might be an empty object or it might have key values inside of it. And it will always have the same output per input. Okay, so this is a function. Okay, so why on earth do we need functional programming? How can it help us? There are a lot of features that functional programming has, but the most important ones, in my opinion, are these five. The first one is that they are reliable. You can trust a function that always returns the same thing. So that's the first and most important part of functional programming in JavaScript or in any other language. And the other thing is that they're portable. You can you can easily pick a part of a code and use it in another project or move it from file to file without breaking anything, and it can easily be used everywhere. And as I said, it's reusable, so you can create a whole library of um, functions and you and all the projects that you know in all the projects that you have, and everyone all around the world could use these functions. Something like Lodash, as you can see, Lodash has a whole set of reusable functions. And it's also testable because you know what sort of output to expect based on a certain input. So that's what we write unit tests for. We check that a function produces or a component produces the desired output based on a given input. And the next part is that we can add properties or contracts. This is the most important part that we'll be talking about throughout these few sessions. I want to explain it in deep here, but we'll get to it soon. Just to just to give a little example of what I mean by properties. See, adding is a function that has four different properties. One of these properties is that it's associative. So what does it mean? Associative means that you can either like add one and two together and then add it with three, or you can add one and add it with two and add it with three at the same time. So the result would be the same. This is something that we will see today. And it's also commutative. Commutative means it's no different whether you add x and y together or you add y and x together. The result will still be the same. The next one is identity. So like if you add anything with 0, you'll still get the same thing that you added as the input. And it's also distributive. Distributive means that like if you want to add x and y, uh, sorry, if you want to mix it with multiplication, like multiply x and y and multiply x and z and add these two together, you could just multiply x and add y and z together. We will be taking a look at some of these. Don't worry if you don't understand what's going on here. We'll take a look at it in depth when we start writing some code. Okay, okay, so done with the slides. Okay, so let's make a functional programming project. Okay. Um, so let's add a little file here. We're going to be learning about currying. Okay, currying is a concept in functional programming, and let's add a simple function here, the same function that we just talked about. So it's a function that has um, two arguments as the input, and it returns an argument. sorry, it returns an output. Um, so this is a bit different compared to what we said before. We said each function produces one output per input, but we're doing something wrong here. We're adding two inputs. What we talked about was just one input. What we're going to prove right now is that it's no different whether we add two inputs or one input. Like if we wanted to add one input to the function as an argument, we would like use destructuring or an array or something like that. What we're going to do is we're going to prove that it's no different whether you add one input or as the argument or two inputs or a multiple set of inputs. What I'm going to do, I'm going to increase the size a bit. I did. I increased the size a bit. Okay. So I'm gonna create a function called toPair, and what it does is that it converts um, one input into a pair of inputs, and what it does is that it receives a function, and this function also waits for an input and passes on to the next function, and this function would be calling the same function that we added in the first place, um, but what it does is that uh, sends the arguments in pairs. So what it does is that it receives a function and it separates them and it converts them into, it calls the same function, but using pairs. Okay. So but we're going to check the output of this function. So what we're going to do is that we're going to create a result uh, variable, and we're going to call toPair, and we're going to send add to it as the first argument. As you can see, that's the f function that we're going to send in here, and we're going to send an array. As you can see here, the second argument would be the array of 1 and 2 here. So what we expect to happen is that no matter what the input that we send, so it either sending in a pair or just one input, which would be the array that we're destructuring here, we would still get the same result, which is 3. So I'm gonna run this code here. Oh, sorry, gotta log it first. Okay, so we do get the result 3. As you can see, we would have initially got the same result if we added, I don't know, 1 and 2 here. We would get 2. Sorry, what happened? Oh, sorry, console.log. So we get 2, 3. So as we can see here, no different whether you whether the type of input that you send, like you could send X and Y, you can send an array that destructures X and Y, or you could also do anything like, I don't know, args or whatever. What I want to prove is that it's no different, no matter the type of input that you send into the function. Okay. Um, let's do the opposite of this. Let's also create a from pair function that does the exact opposite of the to pair function. So it's another function. What it does is that it receives the x and y as pairs in the argument, and then it runs the same function on it, but in the array form, and sends just one input to the function. So let's create another um, variable for result 2. And so this is going to be from pair, okay? And we're going to be from pair to pairing. So we're going to see if we do the reverse on a two pair, if the result is going to still be the same or not. And we're going to pass in add to the function. And what we're going to do, so as you can see, from pair requires a function. This function is calling to pair, which also has add as the input. And the next thing that we have to pass is the input separated, the input paired together. So we're going to be sending in like 1 and 2 here together, and then we'll log the result. Okay. So as you can see, we still got the 3. the result is no different. So whether you had X and Y here, or you had an array of X and Y, the result would have still been the same. Therefore, it's no different. And as we talked about it in the beginning, whether you have one input or a pair of inputs, the result is still the same. We could also do the same if we wanted to flip the input. So if we had const flip, it's a function. As a second input, we want to get y and x this time, on x and y. It would be the same as if we ran it on x and y. So what we do is that let's create another result. And we're going to call flip, pass add as the first argument, and then we're going to pass 1 and 2. So the result should be, again, 3. And as we see, oh, sorry, I haven't logged it yet. Okay, so we've still got our 3s here. And so these were the two properties that we talked about here, associative and commutative. As you can see, we can change the order, or we can send in multiple different types of inputs into the function. But what we want to talk about today is using currying. Now, as you could see here, what happens is that when you pass a function, it remembers that when you create functions like this, what it does is that when you invoke the function itself, when you invoke flip with the function as the input, it waits and it remembers for the first input, and then you can do things based on this first input that you provided to the function. We'll see this a bit in details with the examples. So let's create a curry function, and this is a function that we're going to be using a lot throughout our tests here today. And what this curry function does is that it waits for an x, for instance, and then it waits for another variable. So it waits for the first variable and then waits for the second variable, and then runs the functions with the same pair, with the pair of x and y. Okay. Um, this might be a bit too much right now, and you guys might be wondering what's going on here if you haven't seen functions working like this. Let's see an example to clarify it a bit. So what we're going to do is that we're going to curry the add function. So we're going to create a function called curry add. And what we do is that we pass add to the curry function. Now we have a curried add function. And we're going to create an increment function based on the curried add function. What we do is that we pass 1 to the current add function. So what happens is that when we pass 1, the 1 is the x, and so what it does is that it waits for the x, and it does the addition based on the x. So what we have here is the function that gets run is add 1 and y. So whatever we pass to it, whatever we pass to increment would be the y value. So what we're going to do is that, so right now, what happened here is that we have an increment function, and this increment function can be used globally. What it does is that it adds 1 to whatever value is passed to the increment function. Um, let's create a variable as we had before, result 4, for instance. And what we're going to do is that we're going to for increment, and we're going to pass a random number, let's say 56. So the result of 15, the fourth result, or result 4, should be 57. Let's give it a go and see. As you can see, yeah, with the result that we got is 57. So to wrap this all up again, what happened is that we curried the add function. We can curry any function that we want, as long as it's a function based on those 3 rules that we talked about previously. We curry it. And we can create, we can override those input values of the curried function. So we have overridden the x value, and uh, this is like an instance of that function that always has x as 1. So let's take a look at some. We talked about the pair and the two pair and from pair functions here that were the opposite. Let's take a look at an uncurry function. An uncurry function should also have the same result. So if we wanted to have an uncurry function, we'd have a function that receives the pair, and what it does is that it runs the function for x, and then it runs it for y as the inputs. So this should be also the same, but we don't really want to run this here. It's obvious that it'll work. It's like the two pair and the from pair functions that we had above. Let's take a look at another example. Let's say like we have a, I don't know, modulo function, whatever. And well, what we want to do is the main function that we have is that it's a function that receives x and y as a pair, and it returns x modulo y. So this is the function that we're going to be uh, currying right now. So what we do is that we can call this, I don't know, some function, okay? And in like the same example, like the previous example, what we do is that we call it, um, well, let's call this modulo, okay? And let's call it curried modulo. And what we do is we curry modulo, okay? And so what this does is that now we have a function that can receive one of the, well, it can receive a static value for x and then keep on doing the same thing for the same x. For instance, let's create an is odd, or I don't know, is even, whatever, is odd function, and this is the it's the current function, and what we pass to it is, for instance, 2. Sorry, current modulo, and what we do is we pass 2 to it. So what this does is that um, it always calculates 2. So what happens inside the modulo function is that it always calculates 2% y. Um, this will not work because we would need 2 on the other hand, on the other side. So we'll change the order here. So therefore it will become y% 2. Okay, so we have the current modulo function, and we've called it is odd. Now we can test is odd for different values. So for example, we can console log is odd for the value 5. 5 is an odd value, we run it, we get 1. So 1 means yes, it is an odd value, and 0 means no, it's not an odd value. So for example, if we change the value of 5 to 4, we run it, we get 0. I hope you guys are getting the hang of why we are using curries. Uh, let's talk a little, let's have a few more examples that, that can clarify it a bit more. Okay, so let's have a filter function. And what this filter function does is that uh, before I talk about the filter function, uh, if you notice, the first thing, the first input that we have is the it could be either a function or the static part. You should always have the data as um, the final the final argument in the function. As you could see here in this example, it would have been a bit difficult if we wanted to achieve this without having the y at the end. We'll take a look at a deeper example here. So let's have a filter function, and what this filter function does is that um, it receives a function to do the filter based on that function, and it also receives a list of items or whatever. And what it does is that it filters those items, and it runs that function that we provided to the filter function for it. Let's curry this. So we'll call it a curry filter. And what we do is we curry and add filter as the function to the curry function. Okay. And let's add let's create filter, I don't know, odds function. And what this filter odds function does is that it's an instance of the current filter function, but what we pass to it is the is odd function that we um, defined here. As you can see, there's a lot of chaining, kind of like deep currying is happening here. Is odd itself is a curry function, and curry filter itself again is another curry um, function, and let's test it out. So we'll have a variable called result 5, and we'll call filter odds, sorry, and we'll pass an array to it. So let's say, for example, 1, 2, 3, 4, and 5. What it has to do is that it has to filter the odds and, sorry, forgot to log it again. Okay, so as you can see, it has filtered the odds for us based on the function that we provided, and the function was the is_odd function. And so as you can see, the best possible way to achieve this is to pass the values as the last function, as the last part of the function. So if items was before f here, then you'd be running into serious issues. So the best practice here is to keep the things that you want to be remembered by the curry function. So what happens is that the curry functions remember things. For instance, f, or here it remembers the x value or whatever, and then send the data that you want to send in as the last part. Let's take a look at another simple example. This is going to be the last example. Let's have for instance, a replace function. And what this replace function does, again, it receives a regular expression. It receives the replacement that you want to do. What we're doing is like we're creating string dot replace. And what it does is that it gets the string or whatever the string was before here. And we're going to be creating this. Uh, this would be the regular expression or whatever, and then you'd have the replacement here. Sorry, then you'd have the replace value here. So we're doing kind of the same thing, and as we previously mentioned, we'd have to send in the data in the end. So we'll call this string or whatever. Delete this for now. And what it does is that it gets the string, runs replace on a normal string functions, and it gets the regular expression and the replacement. Okay, so let's create a curried version of the replace function. And so the curry, we send in replace as the function. And let's create a function that only replaces, let's say, the word an or the or whatever. So let's call it replace the the or whatever. And we'll carry replace, and so we're going to be sending the regular expression here. So as the first item, so the first input. So let's say, I don't know, the, whenever you see the, case insensitive, global, all over. And we're going to have the replacement, I don't know, replace it with an or whatever, or replace it with a couple of question marks. Let's test it out. So we're gonna have another result number 6, and we're gonna call replace the, and let's have a string that is the basis of the people that the whatever, and let's log result 6. Okay, yeah, so we did, yeah, what we have to do is we do need to add another um, input here. Again, our curry function just supports 2 inputs, but we could keep on extending our curry function here, but there's a better way to do it. And it's using something called Ramda. I don't know if you guys have seen Ramda before, but Ramda can help you out in these cases, but it supports uh, any number of inputs that you desire, so there's no need to keep on extending or even creating the curry function. Let's add Ramda here. Let's make a project out of this, and actually, yeah, I have it here. Okay, so let's use Ramda instead of our curry function. So what we're going to do here is we're going to um, destructure Ramda. Sorry, we're going to destructure curry from Ramda, and we're going to comment our own curry function. And so let's say we don't have this. Let's see if everything is still working as it was previously. We run it. Yep, everything's working as it was previously. Um, let's uncomment this code and we run it. And as you can see, it's run correctly. I do recommend using Ramda for creating currying functions. And as you can see, the D's have been replaced with the five question marks here. So this was an introduction about currying. There isn't that much more to it, but we will be using currying um, in the future when I talk about a bit more advanced topics.